All right, in this video, I'm going to walk through all of the calculations involved in the SNAP lab. As you can see right here, I have some sample data already filled in my data chart. A note, this is not correct data for you to be using in your own journal. All right, I'm going to say that again. I do not want to see these numbers in your journal upload. This is sample data. It is not appropriate for you to copy these numbers and use it as your own. I am just using these numbers to show you the process that you're going to go through with your own data. So the very first thing that I want to point out before I go to anything else that's in the chart is I have a tube length and then I have total distance. Notice that these two numbers are not the same. The reason for that is that the length of your tube is from the opening to the end, okay, front to back. The total distance that your sound travels or that your snap travels is going to be from the open end down to the back and then back to the open end again. So it's traveling the length of that tube twice. It's going all the way down and coming all the way back. So the total distance that our snap sound is traveling is going to be twice the length of your tube. So if you've not already done so, take the tube length that you have written in, multiply that by 2, and fill that in for your total distance. You're going to need that. The second thing that we're going to do is to find your time interval. And you can see that I've already filled mine in. But the way that you do that, where your snap starts is your TI or your time initial. Where your echo starts is your TF or your time final. So how long did it take the snap to go down the tube and come back? I want to know how long it was in between those two. So for my interval, I always do final minus initial. So you're going to take your echo start time minus your snap start time, and that's going to give you your interval. And I will just show you that right here. My echo start time, 0.0125, minus my snap start time, 0.0047, is going to be this, 0.0078. Be very careful about your decimal places. If this number is negative, you've flipped your numbers around. Make sure that you're doing your echo start minus your snap start. So once you've got your interval for all 6 trials, now you can calculate the speed. And you can see that I've written in here V equals D over T. This goes all the way back to the very beginning of the year. So velocity is distance over time, or displacement over time. How far did the thing travel divided by how long did it take? So in this case, our D is going to be this total distance every single time. So we're always going to start with that. Our T is going to be whatever the interval is for each trial. So I do want you to show your work. So for trial 1, I know that my distance is 2.634 meters. And my time for trial 1, 0.0078 seconds. And I plug that into my calculator. 2.634 divided by 0.0078. 337.69237, blah, 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 blah. So in this case, just to keep things simple, I'm going to just round to my tenths place. And so we're going to call this 337.6 337 meters per second. 337.7 meters per second. And I'm going to write that in my data chart as well. All right, in my second trial, same distance, 2.634 meters. And this time I have a different time interval, which is 0.0080 seconds. And when I plug that in, I get 329.25, or again, I'm going to round to the tenths place and say 329.3. And when I look at my chart, I can see that trial 3 and trial 4 had the same time interval. So I don't have to do that calculation twice. I'm just going to say 3 and 4. So my distance, 2.634 meters, divided by my time interval, 2.634, whoops, 2.634 divided by 76 gives me 346.6 meters per second. And I'm going to write that in for trial 3 and trial 4. Trial 5 is 0.0077 seconds. Gives me 342.1 meters per second. And I'm writing that in my data chart as well. And the last one, I can see 0.0078 seconds is the same as my first time interval. So I can go ahead and copy this down here, 337.7 meters per second. And up here where it says number 1, I'm going to also put in number 6. So I know that both of those trials had the same time interval. So now my next step is to find the average speed based on my calculations. So to find average, you just add up all of your numbers and then divide by however many you have. So in this case, I'm going to do 337.7 plus 329.3 plus 346.6 plus 346.6 plus 342.1 plus 337.7. So that equals 2040. Divide that by 6. And it actually comes out perfectly even, 340 meters per second. Yours may not come out perfectly even. If it doesn't, again, just round to that tenths place and that's completely fine. Now, what are we going to do with all of this? Well, now we're going to do some analysis questions. So you should have already copied the questions and the equations. So we're going to use this equation to calculate the classroom temperature based on my average speed of sound. So if I had to guess what the temperature in the classroom or inside the tube was going to be just based on my calculated speed, this is how I would do it. So my average speed minus 343 meters per second, which, as you know from your notes, is the speed of sound at room temperature, in room temperature air. I'm going to take that difference divided by 0.6 meters per second, which is how much the speed changes for every degree difference. And I'm going to add that to 20 degrees Celsius because this first part right here tells me how much difference is there in the temperature. And the 20 is kind of my base point. That's what I'm starting with. So based on my calculations, I'm going to come up with a temperature. And the first thing I'm going to do is to plug in my number. So my average speed, remember, was 340 meters per second. And I'm going to just copy the rest of the equation. You should be doing yours right now as well. With that first number, whatever you calculated, everything else is the same. So now we're going to plug it in the calculator. And the easiest way to do that, to make sure that your calculator is not missing anything, is to do it piece by piece. So I'm going to start by saying 340 minus 343, and then I'm going to hit equals. Okay, so my calculator knows that this is the only thing I'm subtracting. Now I'm going to divide that by 0.6, and I'm going to hit equals again, so that my calculator knows that's the only thing I'm dividing. So I have a negative 5 degree difference. I'm going to add that to 20, and based on my calculations, the temperature inside my tube should be only 15 degrees Celsius. So what that means is that it should be colder than room temperature inside my tube based on my calculations. So 15, and our units here are degrees Celsius. That's my calculated classroom temperature. Now the second question, let's calculate the actual speed of sound in the room or in the tube based on what we're going to measure with a temperature probe. And so you're going to have a measured temperature from the video if you're watching this from home, or from your actual temperature probe if you're doing this lab in the classroom. So that's the temperature that you're going to plug in here. So I'm going to say that the temperature in my room that I'm in right now is 17.2 degrees Celsius, because it's a rather chilly room that I'm in. I'm going to plug that into the rest of this equation. And again, you should be doing the same with your data that you have gathered from your lab. And then we'll plug that into the calculator. So 17.2 minus 20, that's our difference from room temperature. And we're going to times 0.6. That tells us how much the speed is going to change from normal speed of sound. And add that to 343. So 341.32 or 341.3 meters per second is what the actual real speed that sound moves in this room that I'm in right now. And it's a little bit lower than that 343 because if you remember from your notes, hopefully you do, sound moves a little bit slower in colder air. In warmer air, it moves a little bit faster. So let's do this last one. Let's find the percent difference between the experimental speed, which is what you got for your average speed of sound back in your data chart, and the actual speed based completely on the actual temperature in the classroom. So actual speed is whatever you got here for number 2. So in my case, that's 341.3 meters per second. Average speed is whatever you got way back over here in your data chart. So mine is 340, yours will be different. And I take that and put it over the actual speed again. And once I've done that, I multiply by 100 to get my percent. So let's plug that into the calculator. Okay. And again, I'm going to do this in pieces so that my calculator understands what I'm trying to say. So 341.3 minus 340, hit equals. So I know that that's all I'm subtracting. Now I'm going to divide by this number on the bottom, 341.3, and I'm going to hit equals again. And now I want that in a percent, so I'm going to times 100. And this is my percentage. You can round it to the tenths place or the hundredths place, so either 1 or 2 decimal places. I'm going to say 0.4%. Okay, and that is my final answer. Now, for your lab quiz, you're going to be taking a picture of your journal and inserting it into a question. You're going to actually insert into the question so that I can see it when I'm grading and not just attach a file. So please make sure that you're following the directions. And then you're going to answer some questions based on some other hypothetical numbers that you might plug in. So you need to be familiar with the process for those 3 analysis questions so that you can do your quiz correctly. And that's it. Let your teacher know if you have any questions.